Now, of course, we all understand that securing data is a critical aspect of modern software development and operations. Ensuring the confidentiality, integrity, and availability of data involves various techniques and practices, including encryption in transit, encryption at rest, so this is where the data is stored, and of course, access control lists or ACLs. Working through this module, you're going to understand a little bit more about these topics for the DevOps Engineer Level 4 Knowledge Area K16, how best to secure your data. Now, when we begin, we can take a look at encryption in transit, ensuring that data is encrypted between different systems. Now, this might be between a client and a server, or even between two servers. The idea is that we are preventing unauthorized access or tampering during transmission. Looking at the main principles, we have protocols such as TLS or SSL, so our transport layer security and our secure sockets layer. TLS is just a later implementation of SSL. With HTTPS, this is an implementation of TLS and SSL, ensuring then that our HTTP traffic is encrypted between the client and the web server, or as we said before, technically this could also be between servers. With VPNs, or our virtual private networks, all data between a client and a server will be encrypted irrelevant of the protocol that is in use. Everything goes through the virtual private network. This is also could be between two offices, so transmission between Office 1 and Office 2, all of that data is encrypted through the tunnel. We can also create our more user-specific tunnels, such as SSH tunnels between devices. So tell me you're ready to begin your journey by taking a look at secure tunnels using SSH. Let's take the scenario where you have an HTTP server that is perhaps an embedded device that cannot be upgraded to HTTPS. You need secure communication from your laptop through to this device. Well, the really nice thing about this is it's relatively easy to set up if you're using Linux. I have a couple of Rocky Linux systems here. One is acting, let's say, as my laptop, and the second is then acting as my embedded device that is only working with HTTP. So if I try curling 172.16.247.158, I think should be the IP address, I get my secret site coming out. However, because it's such a secret site, I'm concerned that my communication is in clear text over the network. So, of course, I need to be able to protect it. But it's an embedded device. It doesn't work with HTTPS. So what options are open to me? Well, we can go through and run SSH. And I'm going to put in a few switches. So we're going to specify to run SSH in the background. And the uppercase N is say don't run any commands. I don't really want to SSH into the box. So we just need to set up the tunnel. We're going to be listening on port 8080. And that's going to be on our local host, so on my laptop. So I'm going to be connecting on my laptop. My laptop is going to make the tunnel through to port 80 on the remote system. And we access that through Vagrant and then if I use escape and dot, I can get the IP address back up. It's my last argument. Escape and dot brings up your last argument. Now I'm being prompted for the password. I could obviously use key-based authentication, but for a simple demonstration, I haven't set that up. So you can see now that I'm back on my Rocky system, but I've established an SSH connection to the remote system. If I look at SS-NTL, we can see then that we are in fact listening on port 8080, and we can then go through and use the curl command, localhost port 8080, and we get the website coming back. But the traffic's gone through to my local host. It's been sent through encrypted on port 22 to the remote web server, where it's been passed through to port 80. Now this should time out automatically based on the client alive timeouts. However, if we want to get rid of it once we are finished, we can go through, and if I use pgrep to search for processes for the user Vagrant that have got SSH in their name, and we can see, well, we get a couple coming back. But if I look for a little bit more detail, I can go through and specify a longer listing. So I'm just putting the L in front of the U, and we can see, well, one is the SSHD connection. So this is more managing my client connection as I've connected into the Rocky One system. But my client connection out is then what we're seeing in 6170. We can always check that with more details. If I look at PS minus long for the process 6170, and we can see, well, it looking good. Let's do a full listing as well. We'll get more of our client command in this now, and we can see then that is then my command. So I can go through and do a kill 6170. When we go back now and take a look, that process has gone. And obviously when I clear my screen and then go through and take a look at my open ports, well, that now has been taken down. Rather than run from the command line, it might be easier to create your own SSH config for this. So I'm going to go through and look at editing my .ssh directory. I'm working in my home directory. In my home directory, I've got a .ssh subdirectory, and we can then go through and create the file config. If you haven't got the .ssh directory, you can create it, but you're going to have to set it to private permissions, so it should have a mode of 700. When I look at my config file, in here I can then go through and describe myself a host. I'm going to call this host, let's call it my tunnel. Inside of this, I can go through and specify the host name or IP address that I want to connect to. So I can go through and specify the host name, and I can specify the IP address of 172.16.247.158. Obviously, you use the IP address that works for you or the host name. We can specify the user, and I'm connecting as the Vagrant user on my systems. We can then go through and specify our local forward. And this is going to be the same things as we configured before. 8080 on the local host being forwarded to port 80 on the remote host. It's a little awkward, I think, the way that it's written, because it's 8080 on the local host. The colon is just separating our arguments. We can allow compression. So we can turn compression on. That's optional, we don't need it. And we can specify request TTY, and we can set this to no. We don't need a terminal opening. So once we've got the configuration in place, then I can go through and save this. We do just like the directory. If you needed to create the .ssh directory, it needs the permissions of 700. If you create the config file, then we must set the config file with the mode of 600, so it's private through to the user that created it. Otherwise, SSH won't work with it. I can then create the tunnel, so SSH running in the background, not requesting any commands, and running the my tunnel. Everything else is then specified within my config. And I say, ideally, you'd have key-based authentication, but now I can go through and curl to localhost on port 8080, and I get the secret site coming back in. And again, I can allow this to time out through the normal SSH mechanisms, or I can go through and kill the process. If you need to create the tunnel infrequently, then creating the definition at the command line might be the way to go. And you can see that we can use SSH minus lowercase f to specify the SSH command runs in the background, the uppercase N specifying not to run any SSH commands once connected, and the L for listening. We're listening on port 8080 on the local host and redirecting to port 80 on the remote host. We're connecting as the user account user to the server that we've called, in this instance, web. For something a little bit permanent, we can make sure that we create an SSH config for this. You have to ensure that you have a .ssh directory in your home directory, and it needs to be set with private permissions. Using mkdir -p, it doesn't matter whether the directory is there or not, it won't error if the directory is already there. We can then create a config file within that subdirectory, defining a host called mytunnel, setting the correct host name, the correct username, setting our port forwarding, allowing compression if we need it, and specifying that we don't need a terminal. The config file also needs to be private. It doesn't need the execute permission because that's needed to enter the directory, but not a file. So the file should be set with the permissions of 600. The ease of connecting now is shown where we can just specify SSH -fn mytunnel and we are good to go. Okay, so we've covered encryption in transit, but what about the opposite side of transit? Encryption at rest. How do we manage that? What options are available to us? So this is really where we're talking about encryption on our storage devices. And as we go through and take a look at this, we'll begin by taking a look at file or database encryption, where we can then encrypt files stored on disk and the different encryption libraries that can be used. Then we have full disk encryption. As the name suggests, this is encrypting the entire disk, protecting all data stored on it. And this includes products like BitLocker in Windows, FileVault in macOS, and Lux in Linux. And then, of course, we can outsource to the cloud with managed encryption services. Cloud providers provide this type of storage service where the storage itself is encrypted, such as AWS KMS and Azure Key Vault. And this then simplifies the whole process of managing encryption and encryption keys. As a simple demonstration, we can look at a sensitive file in our Linux file system and look at how we protect it with encryption. And here we are sat at the glorious command line of my Rocky Linux 8.10 system, and a system where I happen to have my company payroll file stored in the file system. We can see at the moment, if I open it up just with the standard tool cat, we can see that it's not encrypted. Maybe this isn't a great idea. Sure, I can protect it with my file permissions. However, if someone maliciously gained access through the admin or the root user, then they're going to have access to every file within the file system. So this really is not enough. So for sensitive files like this, we can consider encrypting them, and we can use standard tools. OpenSSL is always going to be installed in any case. So I can use then the option enc for encryption, and we can specify the algorithm that we want to use. So in this case, we'll use AES-256 with the CBC extensions. We can specify that we use a random salt to help make complexity in the algorithm. And we're also going to use password-based key derivation function 2, would you believe, with PBKDF2 to add, again, more complexity in the storage of our encrypted data. We're going to read in the payroll file, and we'll send it out as payroll .enc for encrypted. It doesn't really matter the extension. Technically, Linux doesn't have extensions, but then we're going to recognize what type of file that is. I then enter my encryption password or passphrase, whatever you like to call it. And of course, I'm going to have to enter this twice just to verify that I have put in the same password. The idea being, obviously, we want to make sure that we have typed the first one correctly. At this stage, I can delete my payroll file. That's the clear text file. But if I try and read the encrypted file, you can see then it's coming back with nothing that I can make sense of. If we check what type of file this is using the file command, we can see that this is an OpenSSL encrypted data with a salted password. So it is securely stored within my file system. So long as I can remember the passphrase, I'm going to be able to get back in. The command is not dissimilar, so I just up arrow key to get the encryption command back, and we just need to change it slightly. We no longer need the salt. The salt is a random string that is added during the encryption. I'm just using the option -D now to decrypt, and we can just swap the files around. The in file now, the input file, is going to be the encrypted file, and the output file is going to be the clear text file. Now this is where I need to remember my password. Let's put the password in, and now we should have still both files, the payroll and the payroll.enc. I can then look at my payroll file, and then of course once I've finished with my payroll file, then I would delete it again. I still have the encrypted version, so I only need to worry about keeping the encrypted version, and of course I shouldn't be keeping the original clear text version. We can now turn our attention to file permissions in Linux and seeing how we can enhance those file permissions by making use of access control lists. It is normal in the Linux file system where we have one user, one group, and then everyone else listed. So it's not ideal, but this is where ACLs will help. I'm working on the command line of my Linux system, and ACLs are really something that we have to look at on Linux. As I say, when we look at our standard file permissions, when I create a file or a directory, really a directory is just a special type of file. We have a single user, a single group, and then everybody else listed through others. So if I create a new directory that I want to be shared out, let's say the socials directory, then when I look at the permissions, so ls-l for a long listing, the -D so we can look at a directory rather than listing the directory content, we can see then that we have the single user root, the single group root, and then everybody else is the third block, and they get read and execute by default. Now this is going to allow them into the directory, and that's the execute permission, to list the contents of the directory, that's the read permission. But then everybody is allowed access to the socials directory, and maybe we don't want that. When I look at my group membership, I can see that I belong to my own Vagrant group, the administrative wheel group, but additionally I have sales and marketing. Maybe the marketing group should have read and write and execute because they're going to own all of the social material, and perhaps the sales group need to review some of the material, so they would need read and execute. Now I could make use of putting the marketing group as the group owner of the directory with read, write and execute, and sales then can pick up through others. But then everybody would have the read and execute, which we don't want. So if I check just the permissions of others at the moment, if I move into the socials directory, well, I can pick up the permissions from others because I'm not a member of the group and I'm not the root user. But of course, I don't have the right access to the socials directory. I only have read and execute. So what we're going to do is first of all go backwards a little bit and remove all permissions granted to others, because this shouldn't be shared to everyone within the organization. So now, of course, if I try and access it, Well, I don't pick up permissions from the user. I don't pick up permissions from the group. So I don't have access at all now to the socials because others do not have permissions. But now we can start looking at setting our access control list. And we do that instead of the chmod command. We've got our set file ACL, -m to modify, and we're adding in a group. We're adding in the marketing group, and we're giving read, write, and execute to the marketing group to the socials directory. Now, as we've already seen, I'm a member of the group marketing, so now I should be able to access the socials directory, so I can CD into it, and then I can create a new file, so I have the right permission. Now we see I didn't have the right permission before, and now I've got both read, write, and execute. Let's test access for our group sales. If I create a new sales user, and we can call that sales user, let's say Anne, I can gain access as that user account by using sudo to switch to the Anne account and an interactive shell. And now as Anne, we haven't added any additional permissions to the socials directory. So if I try and access it, then I'm back using the others grouping. So if I get back to my Vagrant, the administrative account, I can set the access control list now to include a third group. Remember, we have the group owner, we have marketing listed in the access control list, and now we can go through and set sales. But of course, we can set the sales group with just read and execute, just the permissions that they need to be able to enter the directory, list the directory content. But now, as we go back as Anne, we can move into our socials directory, which we couldn't do before. But if I try and create a file here, then this is denied because we don't have the right permission to the directory. A section all about securing data, so taking a look at encryption with things like TLS and SSL. We've seen that we can create SSH tunnels between devices, and we can use ACL's access control list to help secure our data at rest.